Hey guys, Stanford here from the Fun Robotics Network, and right now I'm hanging out with Team 8033 Highlander Robotics here at the Orange County Regional, and we're going to be going through the super slick machine they've got here. Elevator, arm, and an end effector that can do both algae from the ground and coral, a big funnel, a climber, and all the software that powers it. So stay tuned for all that and more in an episode of Behind the Bumpers. All right, Annalise, take it away.
So first we have a two-stage cascading elevator. This is a max height elevator. We made it pretty narrow to avoid racking, and we have carbon tie rods on the sides, which form triangles, so it's more stable. And on the arm, we have a virtual 4-bar arm that can pick up algae from the ground. This has two Kraken Max Planetaries on it, one that controls the arm and one that controls the wrist movement. And we have a 25-to-1 and a 16-to-1. So the arm that moves up and down is on a 25-to-1 ratio, and the one that moves the end effector up and down is on a 16-to-1. This elevator is pretty stable. It has a crossbar, which helps prevent racking, and the four carbon tie rods, which each weigh about a quarter pound.
So what does the design synthesis for this look like? So what are you guys doing in the design process to make sure this all integrates very well?
So first we have individual subsystem CADs, and then we integrate it into the full robot, and we can make adjustments based on which subsystems hit each other, or how the inner support plates, which our drivetrain has two of them, right here and here. And the elevator mounts on top of them with two gussets, one on each side, and that helps help stability.
All right, thank you very much. Let's go ahead and talk about this end effector on the robot.
So this is our end effector. It can take algae from the ground or from the reef and score it directly into the barge, as well as taking coral from the human player station and scoring it on the reef. So as you can see, we have these crossbars that go across the end effector, and what they do is they kind of match the shape of the algae, and that allows the algae to fit in it really well. For compression, we had a lot of inspiration from the WCP competitive concept, which had an end effector that was somewhat similar to this. For coral, we have two sets of compliant wheels up here, as well as a silicone roller with some grip tape at the back. This is all powered by a single Kraken X60, which and everything is rigged together through gears and pulleys and belts. There's a plate over here which serves as support for the coral, but it's also like a crossbar, cross plate, and it makes the end effector more rigid. Additionally, the wheels over here are for the algae. Essentially what they do is manipulate the algae and put them on the reef. Over here are our beam brakes, as you can see, and finally over here is our centering to, as soon as it exits the funnel, we can make sure that it's ready to go on the reef without actually.
So what were some of the different iterations you went through when you were kind of prototyping this and getting competition ready for it?
So I remember on week 1 there was the whole algae fiasco, and we had the problem with the clamshell algae. So we were originally wanting to pinch it, but that's harder to do with the crosshatch algae. So we went for a design like this. I remember at the start we also ditched the idea of a ground intake for this regional. But the idea with that is this end effector could go through the whole robot. Otherwise, the design process was largely prototyping, and once we got the compression right, we modeled this whole thing out in a high fidelity block CAD with all the motors and belts.
All right, very cool stuff. And let's go ahead and talk about this funnel and climber.
Yeah, so we recognized kind of without a coral ground intake, it's gonna be really important to have a funnel that is almost full width. And additionally, on top of that, you really want to have that positive control of the game pieces. Obviously, as you're coming into the player station, you're going to want to be accelerating back forward. But if coral is sitting in your funnel and it doesn't have something actively holding it there, you're going to have to wait until it indexes. We didn't really want to do that. So what we did is we went and stuck some star wheels at the bottom of our funnel here. These are powered by a single Kraken X44 on the underside. And it's kind of dead simple. I mean, we have a one-stage reduction and then a twisted polycord that's about all you need. What we find this does is first of all, helps with indexing, so it gets rid of a couple of jam cases, and also it gets us that active control. So being able to essentially run into the player station and then immediately accelerate, because that coral is not going to fly out as we accelerate. Now, once we actually are ready to climb, obviously the chain is going to have to go right through here. And so what we did is we put 2 servos on the underside, and they have these little hooks that grab the funnel trapdoor, as we call it. Now the key here is that the servos aren't really doing a lot of work. Since this is flush here, it's kind of held close pretty much passively, but at the end of the match these servos will open, and that will allow this to open up like that. Now this isn't big enough for the cage, but it is big enough for the chain, and the cage actually goes under here. So when we deploy our climb, what's going to happen is that this little bolt here gets pushed down by a cam, and that will cause the foot to go ahead and go down. And this foot is just long enough to hold the cage far enough out that it will clear the funnel. The chain goes through the middle, and then this guy essentially locks in there, and that is our deep climb. So I think it's about as simple as it could be, and we like that because it's light. Yeah.
So is there any kind of latch or anything holding that little foot down?
Yeah,
or is it
so,
just the circle tubing?
What's really interesting is that a lot of teams, I think, thought that you had to hold it down with a lot of force. And Rembrandt's has this like fancy over-centering linkage, which is really cool. But what we figured out is that if you actually think about where the forces are when you're climbing, you have a chain pulling up. That's about this point, which acts as a fulcrum. And so ultimately, most of the force pushes down into the bumper. And so as long as your foot tries to hold the cage out and not down, you don't need to lock it. So when we climb, at the very beginning, it comes up a bit, but then once it passes the over center point, it slams back down. And from that point on, the cage is just pushing it this way. It's not going to come up again. So we can save that complexity by playing with the geometry a little bit.
Wow, there's some really smart stuff there. Let's go ahead and talk about the software that makes all this thing go.
So we've got a lot of really fun stuff going on in software this year. A lot of it is building off of software we've worked on in previous years. You can see on our robot, we've got 3 camera mounts on top of our swerve modules. Like last year, we wanted to make sure our cameras were super rigid, so we printed them out of nylon, put them right on that drive base. The one in the front here is positioned to see tags on the reef while we score, which has been super helpful for keeping a consistent, accurate pose estimate. All 3 of these cameras are OV9281 ArduCam cameras, plugged into Orange Pi's running Photon Vision. Very similar setup to what we had going last year. We've just done a little more tuning to get a little bit more precise, because we need to be a little more precise with our scoring this year. That pose estimate feeds into our auto aligns. So we have an auto align for scoring coral on the reef, for picking up algae off the reef, and for scoring algae in the net. And all of those have been super handy this season for making sure that our driver is able to think about the high-level strategy and not the low-level scoring. Part of what makes our robot so reliable is some changes we made to the structure of our code in the off-season. We use WPI's command-based format, but we've added on top of it a what we call a superstructure state machine-based system. So this is taking a lot of inspiration from teams like 5940 Bread and 2974 Walton Robotics to really clearly map out what our robot can do and the different states it can be in. This has been super helpful for organizing our code and making sure that the robot does exactly what we tell it to and always knows what's going on. We developed that system in the off-season, and it's available. Our code is all public on GitHub. We also make extensive use of simulation in our robots. This has been super helpful, especially with the Week 1 tournament this year. This is our first time ever coming to a Week 1, so we needed to be extremely prepared coming out of the gate as soon as the robot was handed over to software. As part of this, we do full robot simulation, so everything on our robot is simulated in some way, shape, or form. We've made extensive use of libraries such as Photon Vision simulation and MapleSim simulation to make sure that we have sufficient fidelity of our simulation to test all the features we want to test. So as part of that, we have a full simulation of the way the robot moves. So we can see here as it runs some auto-aligning features. We can also see right here, we've got our algae intake auto-align running as it lines up near the reef. And we can see how it has collision detection in sim all of this has been super helpful for making sure that the robot is ready to go when it's handed over to software.
All right, folks, so that was your look at this 8033 machine. You guys have been looking incredible here at the Orange County Regional, so definitely give these guys a look at future events. They've been really doing a great job out on the field. So thank you guys so much for allowing us to come by and take a look at this robot, and good luck with the rest of your competition.